everybody. My name is Roberto Bonomi, and I'm the sales manager for CS SPA. CS SPA is an Italian company. And we have a railware division, that is the electronic division of CS SPA. My background is in the railway field is very long. I moved from different company. And now I'm involved in sales. Of course, we are product manufacturers, so the sales is very technically, so I'm in charge about all the different markets that include Europe, China, Japan, and USA. Okay, my presentation will be about something new on the energy metering. That starting from the new standardization, so there is a new version of the EN 50463. It was approved in March, the new version 2017, and according to the Senelec process, this standard will be applicable, is DOP, next year, so 2018. This standard will be published, so it means that the new project will require for sure these new standards. And for the actual standard, that is the 2012, it will be removed in 2020. That's the planning from Senate. What is the big changes? As you know, probably there is this standard is divided in 5 parts. There's 2, there's 3, there's 4, and there's 5. The most changes, the majority of the changes is in the -4. That is the part of the standard dedicated to the communication, so the way in which the energy metering transfer data to the server. So there is some big changes, especially in the data format. All the data is XML file, but in the new standard there are a new complete structure, more complex than the previous, than the actual. And also the CBD, that is the file that contains the energy data for billing, compiled energy billing data, that stands for CBD, is protected with digital signature based on RSA SHA 256. So it means that the file is improved with a digital signature. Of course, we have a space to add not only signature but also some encryption. Standardization of the communication protocol, so it's specified not the previous FTP, but there is a concept of a mailbox, so it's a little bit more complex than FTP to be transferred from the meter to the ground. And another big change is the separation of the contents of the data. From the metering we have a different data, billing data, and also maintenance data. So we have different communication channel. So the meter can transfer, using the new standard, different data according to different services. There is also some maintenance service added, and also there are some extension, custom extension, that the standard is open, so we can add more functionality on this communication channel. Last but not least is the supported multiple DCS. So the new standard specifies that the meter can send data also in parallel to a different DCS. Different DCS is data collection system, is the ground server. That could be in one country or in different country, so in parallel. And we can have multiple DCS. We have DCS, for example, for maintenance or also for the billing. So this is the general overview of the standard, different train. Send data using the new protocol now is standardized, it's a passive FTP with integrity verification, and the mailbox message is structured. So the train is moving data from train to DCS, and the DCS is connected to the billing server. There are different billing servers, of course, in the market, and different DCS. But the news is that the protocol is standardized. So with the new standard 2017, the protocol is standardized. So there is also some configuration in which the train can send data directly to the billing. In this case, the billing acts also as a DCS server. There is also some maintenance server directly connection to the train, and okay, and that's it. What is the impact and the benefit of the new standards? Okay, the first one is very important. DCS can accept the communication from different meters available on the market, so it's a sort of interoperability features. The energy data is more secured because there is a complex signature to calculate inside the meter. So that's the reason that the meter need to have a powerful CPU, a powerful operating system, and so because this calculation is a big effort for the device. Okay, we have an extended capability with the customer application because the standard lets some fields open, so we can fill with additional functionality. And this additional functionality is what we call is carry on using reading block instead of CVD. So the impact for the energy meter available on the market is that the old energy meter available on the market, in order to fulfill this new standard, need to be replaced in hardware and software, of course. The energy and maintenance data is now clearly specified. And also another features is that the EMS, so the energy measurement system, is now integrated with the TCMS, with the IC 61375. And also there is some device diagnostic using event communication. There are another channel of communication that is called event. Okay, so in summary, we have a new protocol, okay, that carry on different communication channel, CVD, reading block, and event. CVD is for billing, everything is specified. We have to move data from train to ground server. On the reading block and the event, we have optional field, so we can use this with additional information, train diagnostic, remote condition monitor, alerts, and so on. And our solution, of course, is based on a product that we call ECOS platform. So ECOS is not energy meter only, it's a platform with an hardware, an operating system, and a middleware. And on top of this, we can add a different application. So in this case, is the actual standard 2012. So we have energy measurement EMS according to these standards, but we can add also the new standards. So it's an independent process. So in this case, we have an update energy meter. And then we can add some diagnostic functionality. Some diagnostic functionality is based on EN 5163. That is the standard that defines the catenary parameters, voltage, the current, the spikes, the drop, and so on. And then we have additional functionality like data logging, like TMS data reports, and so on. That's the ECOS platform. So it's more than even the energy meter. It could be also a diagnostic unit integrated in one device. So for the compatibility with the actual standard and the new standard, we already developed everything. It's based on web configuration, okay? So you can connect to the device and decide if you want the previous standard, the actual standard, based on FTP, or you can have also the mailbox solution. So if you put some configuration on the mailbox, the device is running on the new standards. So one device can meet the actual and the new request. Okay, some information about the device. The device has, of course, is EN5155, wide range. We have 4 analog input for the sensor, could be DC or AC, and we have up to 8 distributed DC channel for distributed measurement. So it's very complex. So we have different implementation. We can have a single point of measurement or multiple point of measurement. We have a different TSMS and maintenance port on Ethernet, an integrated Wi-Fi access point. Can be this access point is configuration can be turned off and according to configuration behavior. We have a localization, and TCMS localization can be through the GPS or the TCMS. And also we have different radio interface, 2G, 3G, or 4G. Okay, this is our distributed measurement solution, is ECOS Micro. is based on ECOS generation, of course, ECOS device. But the difference is that we have a smart meter, so meter that can be distributed in the train. This is applicable, for example, in EMU, in which for each sensor we integrate the voltage function measurement, VFM, and also the current function measure. So it's a sensor that integrates the voltage, the current, and also the energy calculation functionality. And the 8 sensor, up to 8 sensor, is connected to the digital channel to the meter that act, in this case, as a DHS, so data handling storage, is the server for the energy metering. And the device, the DHS, can be also the train-to-ground router. This is an overview of the configuration and the dashboard available on the web. We have a free virtual channel with 8 distributed channels. The 8 sensor can be connected using Ethernet, RS485, and MVP. Of course, this is a private network, so nobody can attack this network because it's completely isolated from the real network. So, typical case, we can have the sensor connected in MVP or in RS485 or Ethernet. This is a real-time monitor of all the measurement that the meter is doing. We can monitor in real time in a graphical way the voltage, the power, the energy, the diagnostic functionality. So we have different view for the metering, for the DHS, we have information for the alarm, warnings, and also some map location of the train. Okay, as I told you before, we have some space in the new standard for optional field, so optional functionality. We add inside the ECOS some diagnostic functionality, and especially we have a real-time catenary monitor. So in parallel, where the meter is running, we can calculate, we can check the status of the catenary according to the threshold specified by EN 5163. And could be also possible to modify according to special needs, some threshold. So if some customer want to have some specific information, we can, of course, adapt. What happened? What happened that when the train is running, it's measure the energy and check the catenary status. In case of detect something wrong, something in error, something in warning, it's store all this information, including the position of the train, in a special database. And this database can be transferred to the maintenance server. That's the main purpose of this. So we have also an interface, a real-time diagnostic with SMS to transfer this information, that is diagnostic information. Okay, this is a screenshot of what we call alarm and warning according to the EN 5163. So with this feature, we monitor the quality, the analysis of the quality of voltage and current and frequency of the catenary. Okay, we add also some harmonic analysis and also FFT, because in the device there is a special DSP dedicated to this. So we can also check the harmonic generated by the train or present in the catenary. So, for example, a typical application is some customer want to detect the 50 Hz that can be generated by the train and can have impact on the signal. Or in some country there is 75, 83, and so on and so on. But in theory, there is no limitation, so we can monitor all the harmonics that the customer needs. And this is a software application completely independent from the energy measurement. The result of this could be sent in real time to the DCMS, or we can send some result, for example, the total harmonic distortion to the DCMS or to a maintenance server. Yes, of course, DC and DC. Okay, we can detect also catenary, pantograph bouncing, because when there is some bouncing, we can have some, of course, harmonics generated. And we have a DSP for custom application. Thank you very much.
Precise on time.